time you go to bed?
I didn't miss anything.
Well, I just kind of got sick for a little bit of school. Is that your track?
All right.
I just passed out for like 4 hours.
Shall we
Jody skipped more school this year than I have.
begin our adventure?
We're just saying, shall
Our sequences and series adventure. Okay, I'll sign it later. Oh. What? No. Answer is no. I gave it good thought and I answered no.
we? You have 5 minutes.
No, you can leave 5 minutes.
Can senior get 10 minutes?
Oh my god.
What?
Alright. Now, we've got 2 things. First, we're going to start with baby steps sequences. What is a sequence?
It's a bunch of numbers
Add them
put
all
together.
together.
No, you don't add them. That's like the opposite of what a sequence is. That's the one you do not add all together. Oh, I like that game. Okay. A sequence is just like a set of number terms where you plug one in, right, and you get the first term.
It's frozen.
Oops, sorry. You plug 1 in and you get the first term. And then you plug 2 in and you get the 9. And then you plug 3 in and you get... Ooh, why is it fuzzy? 27. And then you plug 4 in and you get...
80.
Yeah, come grab one. Oh yeah, it's the whole thing's calculator. And then you plug in the 5th term and you get...
248.
Okay, nice. All right, so it's just the first 5 terms of the sequence, just set in numbers. So,
Is it always 5? Oh, no.
no, it just says first 5. It goes on forever, but... Okay, this one, 2 over n factorial is... First term.
2. No, 0.
No,
Undefined.
it's right, 2.
Wait, not 0.
Wait.
Actually, 0 factorial is still 1.
It's still 1.
Yeah. But we plug 1 in first. And then
1.
next term, 1. Next term,
0.6.
oh my god, why would you do that? So this is like 2 over 3 times 2 times 1. The 2's cancel, so 1/3. Next one,
Let's get down.
1 over 12. So many pages.
okay. All right. Okay? All right. Easy peasy. Now a sequence, so basically here's what a sequence does. You start with, I don't have a pencil. Oh, here I do. Okay, so it's still like, kind of like a function. For example, if I had 3 to the n, it would look like this, right? But instead of the whole function like this, it just takes the values at 1, at 2, at 3, and then you don't have like any of these values in between, right? Yes? For a sequence, it's just those points and it keeps going, and then you have another one at 4 and at 5. Okay. Let's go to writing an expression for the nth term of each sequence. So somehow I need to get from 1 to 3, 2 to 8, 3 to 13, and 4 to 18.
23. 3 plus 5 plus 5.
What do you mean plus 5?
-2 plus
N plus 5. No.
3 plus 5 and minus 2.
Yeah, that's right, Jody. 5, wait, hold on. 5n minus 1. Yeah, 5n minus 1 plus 3. Why is it that? Well, okay, you said it was from 3 to 8 you do plus 5, and from 8 to 13 you do plus 5 and plus 5, right? What kind of sequence is that called? Or Yeah.
Arithmetic.
Yeah.
Ah.
Wait, so
Throwbacks.
capitalized, does he just make one of them bigger?
What?
Because like they're all capital letters, but you made the A bigger anyway.
Yeah.
It's a lowercase capital letter.
So your sequence will be, you can use this formula, the first term, A1, plus your, what you add every time, 5 times, and then you have to do n minus 1, because the first term is 3, and then to get to the second term, you only add 5 once, so that's why it's n minus 1, and then to get to the third term, you add 5 twice, and then to get to the fourth term, you add 5 3 times, right? Does that make sense?
Yeah.
5n minus 2 is still 5, right?
What?
5n minus 2.
Oh yeah, so if you plug it in, that's how you simplified it, right? 3 plus 5 times n minus 1 can simplify to just be 5n minus 2. So that's also a fine formula for your arithmetic sequence. Okay, so that's one of them that you should remember. What's the other one? So I gotta get from 1 to 5, 2 to negative 15, 3 to 4, and 4 to negative 135.
Multiplication.
What does it look like?
Times negative 3.
Every time we multiply by what?
Negative 3.
Okay, what kind of sequence is that? So geometric is when you multiply by a common ratio every single time. So an equals your first term, and then instead of adding, we're going to multiply by r to the n minus 1, because we want to multiply by 3, and then we want to multiply by 2 3s, and then we want to multiply by 3 3s. And so that's your geometric. So if we simplify this, or put this in our formula, it will be 5 times negative 15 to the n minus, no, what am I doing, guys? Not negative 15, negative 3. Thank you. And minus 1. Okay. All right. Next one. I need to get 1 to 1, 2 to 4, 3 to 9, 4 to 16, 5 to 25. So just n squared. That one's not arithmetic or geometric.
How do you call it?
It's just a sequence. Got to get from 1 to 4, 2 to 10, 3 to 28, 4 to 82. And so you can't do plus every single time, and you can't do multiply every single time. It is a sequence.
Neither. It's not. If you guess.
Yes, yeah, yes.
Plug and chug.
Isn't it times 3 minus 2?
I don't think so.
Why?
Wait.
Isn't it just the previous term?
Yeah, but we can't write it in this form. That's a recursive sequence.
Yeah.
That's how it is.
And we're doing
They don't want-
an explicit sequence. I'll help you.
Thank you.
I think it's just moist.
You have to finish it though.
Plus one.
Ah. Okay. Okay. What do you think about the bottom one?
The top goes up by 2 and the bottom goes up by
Okay. Top goes up by 2. bottom goes up by. So we can just do 2 arithmetic sequences, right? So the top one would be 1 plus 2 times n minus 1. And the bottom would be 4 plus 3 times n minus 1. And so we would get
+1.
yeah. Okay. Make a little side note and say, these are 2 that you should know.
Also, my lunchbox kind of smells. Yeah.
So an even numbers always, even sequences always look like 2n. And then odd sequences always look like either 2n plus 1 or 2n minus 1. Like if you look at this, it's going like from 1 to 3 to 5 to 7 to 9 was 2n minus 1. Or it could be 2n plus 1. But both of those are sequences that you should know. Okay? Alrighty? Everybody okay? Alright. Now, determine whether each sequence converges or diverges. If the sequence converges, find its limit.
Isn't it like 1 over a?
Here we are.
Here we go.
It's 1 over a minus
BC cow.
1 over
You're not even there yet.
a. We're not there yet.
Did we do this last
Yeah,
year?
John, you
No.
freaking dummy.
Okay. If a sequence has a finite limit, we say the sequence converges to that limit. Right? If this sequence actually approached a horizontal asymptote, right? Then if the function approached a horizontal asymptote, then this sequence would also approach that number as it went to infinity. Are you with me?
Yes.
Okay. But if a sequence does not have a finite limit, then we say that the sequence diverges. So if the sequence approaches a number, then it converges. And if the sequence does not approach a number, then we say it diverges.
Just like with the,
Yeah, just like regular functions, right? Okay. So it's not too bad. We're just going to see as we go to infinity, limit as n goes to infinity, of the sequence formula. Let's just see if that converges or diverges. If we get a number, then it will converge, and if we don't get a number, then it will diverge. So,
Is there like a test for
nope.
that calculator?
So I'm going to just simplify this to 1 over 2 to the n minus 1. Because 1 to the n minus 1 is always 1. And then we have 2 to the n minus 1. As if I plug in infinity, what does this limit go to? 0. So this sequence converges to 0. Okay? Okay? Now, what happens when it goes, it's the same sequence, but it goes positive, negative, and then it's going to keep going positive, negative, because of that negative 1 to the n minus 1. This is called an alternating sequence.
Is it oscillate or it just points up and down?
It's just points up and down, because they're separate. It goes from 1 to 2 to 3 to 4. So, this is anytime you have a negative to an nth power or a negative to an n minus 1 power or plus 1 power, then it's an alternating sequence. But it's not alternating. Make a little side note on your paper. It's not alternating if it's negative 1 to the 2n power or negative 1 to the 2n plus or minus 1 power, right? Are you with me?
Yes.
Because what is 2n?
Even.
An even number. And then if you have a negative 1 to an even power, it's always going to be positive. And if you have a negative 1 to an odd power, it's always going to be negative. So it's no longer alternating. Important to know for the future. Okay. So this is alternating, and we're going to take the negative out of our limit. So we're going to say negative 1 to the n minus 1. And then we're going to evaluate the limit of the rest. You've already done this. This equals what?
0.
And this means it's alternating, right? If it's alternating and it equals 0, it will converge to 0. But if this if limit does not equal 0, then it diverges. So if the limit does not equal 0 and it's alternating, if the limit does not equal 0 and it's alternating, then it's going to automatically diverge. The limit has to go to 0 if it's alternating. Yeah.
Where did we get the negative 1 to the n minus 1?
We just pulled out, like I made this to this power, and then the 1/2 to that power, right? Okay, let me explain why. Okay, let's say you have a function that is, yeah, I think you're on the right track. So if I have negative 1 to the n power, but let's say that my limit up as n goes to infinity of some function a of n, let's say this approached 3. Okay? So we have this alternating part, but my limit equaled 3. So here's what would happen. As I went to infinity, since my limit's going to 3, my values, just like you sketched the sequence up here, it's going to go from up here, to down here, and then up here to down here. But it's never going to, then towards infinity, it's just going to go switch from positive 3 to negative 3, positive 3 to negative 3, right? Because your limit, this limit's going to go to 3, and then it's still going to be alternating. So it's going to go 3, negative 3, 3, negative 3. But you'll always have this chunk missing right here where it won't like actually approach anything. Right? Yeah, so that one's going to diverge if this equaled, doesn't equal 0. Yeah, but see, if it was alternating for this example, if it was alternating and it equaled 0, you could go, you'd be up here at 1/2, and then down here 1/4, negative 1/4, positive 1/8, negative 1/16, and then you would go super closer and closer and closer to the x-axis, so it would end up converging. You know, are you with me? Okay. Excellent. Man, it's the end of the day, and some of you are passing out.
Yeah.
Wake up. If you need water,
Your thing passed out on the fly.
go get it.
Okay. I'm not like freaking out.
No, I mean,
I think I'll take you over there.
if you need water, go get water.
No, I have water. I got it before class.
If you need to wet a paper towel so that you can put it on your forehead, that's a good idea.
Just stop learning.
Why is that a good idea?
It's snowing again.
To keep you awake.
It's snowing, we need to. I'm always awake.
Okay, come on, guys.
We don't cancel out the question.
Don't make this harder for me.
Okay.
It's already hard for me to teach at the end of the day.
Wait.
I'm not at my prime.
What is it?
We need you in your prime. I need you in your
I'm not at my first derivative.
So
That's enough.
No? Okay.
I might need some more water after that.
I keep throwing these jokes at you, seeing what sticks.
And then we went.
Don't be a third derivative.
Okay, which one's bigger?
The bottom.
No, I'm just a first.
Oh, aren't they both infinity? No.
They both are infinity, but the bottom's bigger, right?
Bigger.
So what's this limit gonna go to?
0.
0.
Okay,
Wait, what?
yeah. Because, you know, it's gonna approach infinity on the bottom bigger, faster.
Okay.
On the top. Now, so, this is a geometric sequence because it's to the nth power. If your r is less than 1, then the geometric sequence converges to 0. Okay? And if we did this,
To infinity.
the top is bigger, right?
Yes.
So this goes to infinity. So if r is greater than 1, then a geometric sequence. Thanks.
Will it always Wait, if it's any number but 0, then it diverges.
No. If it equals 0, it converges.
If it
Or
equals
no,
0,
if it equals any number,
it
it converges.
to that number.
Unless it's alternating.
Okay.
If it's alternating,
That's just
then
when
your
there's a negative.
yeah, then your limit has to equal 0.
That's just when it's geometric and negative.
No, alternating
Alternating.
and it doesn't matter whether it's geometric or not. But if
Okay.
your limit equals 0 and it's
Is
alternating.
it ever going to be arithmetic and alternating?
That's where I'm.
Could be, but arithmetic sequences don't converge.
Okay.
Because when you add a number every single time and when you subtract a number every single time, you're never
It's going to
gonna.
be straight.
Yeah. Okay, your turn. Do A, E through H. Tell me whether they converge or diverge. Basically, all you have to do is find the limit. If the limit exists, then it converges. If the limit does not exist, then it diverges. The sequence.
It's just continuous. Where does it converge? Is it exist?
No, that's the unit circle. Draw a sine curve.
No, the sine curve is a circle.
No, the sine curve is not a circle. You're thinking polar still.
No, but just think about it.
R sine theta.
It's 1. It draws a perfect circle. What are you talking about?
No,
You just don't understand.
keep doing that, Andy. You'll get the answer eventually.
That's how you do your arm workouts, where you
There's only 2 options.
Yeah,
It's 50.
yeah. 50-50.
Yeah, there.
Sure.
Oh, we don't need to talk about that.
No, we don't.
Negative number.
Hey, Luke, you need some popcorn?
I'm alright.
Remember that one day when you offered me candy? Because I was
Does
just
it
like,
though?
keep popping off.
Are you sure?
Does it though?
Yeah, I'm fine.
Does it?
Do you remember that this morning?
What's your last name?
I was like falling asleep.
I know. Do you? Yeah, you were falling asleep.
Because I was so dang I was like not human.
Okay, this one sign does not. The limit does not exist, so it diverges.
It oscillates wildly.
Not wild. Just not wild.
Whenever I do math in this class, I think, what would be
So, Hanwen, I cured your depression.
No.
See, he smiled. He laughed. I should show that video to.
Yes.
I showed this to Hanwen. This guy could stick this in my Kiwi's toilet. Blows off.
What's natural argument?
It's so funny.
It's the one.
I like Annabelle.
Natural.
I have no idea what that is.
I think
And then I showed him of a guy get like shot down in Syria.
increases more than
Muhammad just attacks him. Oh my god. Yo, did you guys watch that video in physics today about like Captain Marvel?
Yeah.
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 He played that in Warhawk Time.
I had to watch that twice.
Warhawk Time.
Wait, so put that video on.
One over a bigger number. Because those two numbers are bigger.
So we're gonna play a video about Captain Marvel today, and it was all about
Captain Marvel, John, you freaking stupid.
Captain Marvel. And it was all about like women's rights. And it was really, really
She was right.
John, can you just do your problems, please? I'll just do the
Kind of. Yeah, it does diverge.
Okay. What is incorrect about it?
Nothing really, but
Nothing really.
you
The way I set it up.
you can't just take out the -1 to the end like that.
Okay.
But it does diverge. You're on the right track.
Okay.
I'll write out a couple of terms of the sequence, and you'll see why it diverges.
All right. Is that one where you do take out a number? Or no?
No,
No.
because it's not multiplied by -1 to the end.
Oh, it's just added.
Did you guys finish?
Why is that? It doesn't really have a limit because it will keep like
Exactly.
will keep flipping back and forth.
Right.
For the last two, where with the factorials, and it goes to infinity over infinity. We'll use the L'Hopital on those.
You don't know how to do the I don't know how to do the derivative of a factorial either.
Just say converges or diverges.
Kind of, but I do want to do a little bit with you about that. So, guys, for F, what did you get?
Converges with 0.
No, wrong.
Wait, what? It doesn't?
Did you say no?
What do you mean
Converges
no?
to 3 over 5.
Thank you.
Converges.
Hey!
Oh,
I got a question right.
Converges to 3/5, right? Because the limit is, you can either do L'Hopital's, but the easier thing is to do the degree of the top equals the degree of the bottom, so leading coefficient over leading coefficient. Because if you're going to do L'Hopital's, you have to do that whole little proof, silly McGee thing. For G, I'm not going to do the limit. I'm just going to do a couple of terms, because 3 minus 1 is 2, and then 3 plus 1 is 4, and then it's going to be 2, and then 4, and then 2, and then 4. So will this converge or diverge?
Wait.
Because it never actually approaches a number. All right, next one.
Is that still defined as alternating, even though it's not alternating?
It's alternating
'Cause it's
between
alternating
2 and 4, but it's not,
It's not the negative.
yeah, it's not negative, positive, negative, positive. Oops.
Oh, yeah. I guess. Isn't the bottom bigger though?
Guys,
It'll slightly big, but it'll be
for this one, if we plugged in infinity,
wait.
Do you use L'Hopital on
it would be infinity over infinity. So in order to use L'Hopital's, remember, let's prove.
Oh,
This was the one.
Wait, what? Yeah, that's when you're multiplying.
I think it is.
So this, since it's infinity on the top and infinity on the bottom, we're going to use L'Hopital. Right. And do derivative of the top is 1 over n. Derivative of the bottom is 1. Plug in infinity, this equals 0. So this is going to converge to 0. Great.
Miss Moy,
Yeah.
since n will increase faster than log natural n, can't you just use that to say it'll converge to 0 off the
Yeah.
bat?
Yeah. If you noticed that this is going to approach infinity faster than this, yeah. Okay. The bottom two down here, we can't really use L'Hopital's for because we don't know how to do derivatives of factorial. So let's do this. Off to the side. If I did 5 factorial, what is that?
Yeah, that.
Right? Okay. But I could also write this as 5 times 4 times 3 factorial, right?
Yeah.
Or 5 times 4 factorial, right?
Yeah.
Okay. So we're going to take this and we're going to split the bigger one, the n plus 3 factorial, into n plus 3 times n plus 2 times n plus 1 factorial, n plus 1 factorial. I'll stop at n plus 1 factorial, and then you can cancel. And then if I plug in infinity, what does it go to?
1 over infinity.
Which is 0. So we can say this converges to 0, right? And last one, which one's bigger, the top or the bottom? What? The top is bigger, so let's split that one up and let's go n plus 1 times n factorial. And so we plug in infinity and we get infinity, so this is gonna...
Wait, how come that D's not?
Because I started to write the C for converge and I wanted to change it.
She's doing reverse psychology. Lowercase first, uppercase everything. But make sure they're lowercase, uppercase.
It's blowing your mind right now.
Boy,
Yes.
this is harder than the math.
Oh, we're doing lesson 2.
Yes.
Oh, it's only one page.
Okay. Now, let's talk about series. Yay. Now,
This week I binge watched the entire Umbrella Academy.
when does a sequence converge? A sequence.
A sequence?
At all.
Never.
When it's not going to when it's approaching an
When the
actual
degree at the top and
OMG, we literally just did
What is approaching
this.
infinity?
Yeah, that's when a diverge is.
Okay, so sequence
Oh,
converges what?
Yeah, I knew A1 over 1 minus all.
Converges when your limit of your sequence equals a number, right? Okay, when does it diverge?
Infinity.
or it oscillates.
Or it oscillates.
Wildly.
Just normally oscillates.
Does not exist. Does not exist, okay? And then when there's a special case, is when it's what? Oh my god.
What is oscillate?
What's the special case?
Alternating, just because the limit exists, right, doesn't mean that it's going to converge. The limit, it's got to be alternating. If it's alternating, what happens? The limit has to go to,
Not 0.
no, it has to
Goes
go to
to-
0
I thought you were talking about
in order,
divergence.
in order to converge.
Okay.
To converge. Okay, all good?
wait,
That's for sequences. Now, we're taking the training wheels off
Wait, training.
Series is the one.
and we're going to series, right? Yeah, series is when you add all the terms of a sequence together.
Can you go back for a second?
Whoa, that's next level.
I have a phobia of letter math.
All right. Now, a sequence is easy. It converges if the limit exists, and it diverges if the limit does not exist. Series, not so easy. Let's see a few series, one that converges and one that diverges. So if we do one that converges, like we're gonna make a sequence of partial sums just to see if the sequence of partial sums will approach a number. So if I go The sequence of partial sums of one term is just 3 halves. And the sequence of partial sums up to 2 terms is 3 halves plus 3/4. Okay?
Oh, this is on the calculator.
Yeah, I'm gonna get you the decimal. 2.25. This is gonna be easier to see if we do decimals. Okay, then a sequence of partial sums up to 3 terms is just that plus 3/8. 2.625. Sequence of partial sums up to 4 terms is 2.8125. And sequence of partial sums up to 5 terms is 2.906. Sequence 6 terms.
So it converges to 3.
Hold on. I'm not done yet. You're ruining the surprise.
Oh, it needs to go all the way.
Oh, it's going to 3.
How do you type so quick? Every time I try and type quickly, it's like, what did you say?
Maybe that's just languages are slow.
Yeah,
Remember what Andrew said? That was so good.
And equals 3.
Oops. So it looks like,
Keep going.
oh my gosh, no. It looks like it's going to
3.
3, right?
But it's not.
All right, so what do we notice about the results? It looks like it's approaching,
So should we do that on every test?
no,
Oh.
approaches
Every single term until you like
3, right? Well, back in Algebra 2, you learned the sum of an infinite geometric series, because this is an infinite geometric series, right? If your r is less than 1, then the sum of an infinite geometric series is this formula, right? You remember that.
Obviously. I remember that.
Yeah. This A1 is your
I know.
your first term. No, you did it in Algebra 2 as well,
Okay, but I didn't actually learn it.
because it was on the formula sheet for the SOL.
When you're learning things in algebra, I just described
What's our first term?
3 over 2.
right? You could visualize it.
And what's our common ratio?
Yeah.
What do we add every time
I don't know.
to get to the next term?
3 over 2.
We multiply.
No, the 3 stays the same. We just add a half.
Wait, no, you multiply by.
Multiply by a half, thank you. So if we simplify this, this is 3 halves over 1 half, which equals 3. So our series converges to 3. The sum of all these terms will approach 3. And we saw that here.
I learned how to count to 5 yesterday.
Okay?
This is getting crazy.
The error in your approximation is just the actual sum, 3, minus your approximated sum. Ours was 2.997. How do we make it more accurate?
Keep going.
More decimals.
Keep adding the terms, right? Then our error will be smaller. Okay, now let's check out this series. For the first 5 terms, S1, 3 halves. 3.75, S2. S3, 7.125. S4. What is this?
That's too big. That's too big.
Oh my gosh. 12.1875. Oh geez, we are increasing without bound.
That's ridiculous.
Crazy.
What do you notice about the results?
Diverges.
Just keep going until the end of class.
No.
You're right, 5 minutes before the bell.
It keeps increasing! Exclamation point! Not factorial. What does the formula for the sum of an infinite geometric series tell you about this series? What's our R?
R is greater than 1.
R is 3/2, which is greater than 1. So, the series diverges. Okay. How do we know
All you have to do.
when a series is going to converge or diverge? So,
R
sequences are very easy. Sequence will converge if the limit exists. It's going to diverge if the limit doesn't exist. There's one special case where it's alternating. If it's alternating, the limit has to go to 0. For series, in order to figure out whether a series will converge or diverge, there are 10 tests that you need to learn.
What?
Oh.
And
Enroll
yes,
in-
that you're gonna have to memorize.
We're taking 10 tests this unit.
And you have to know, I'm not gonna tell you when to use what test. You have to figure out when to use what test. If you flip a couple pages in your book, all 10 tests are listed in a very nice flowchart, slash box.
I saw this and I was
For
like,
you.
oh, the flowchart.
This is ridiculous.
No, you cannot.
I wish I had a photographic memory so I could just look at
So
it.
welcome to series, guys.
Use this on the test.
We have to memorize this whole page.
Or can we?
All 10 tests.
Use this in the real world. Can we use
You're not going to use any of this in the real world, let's be honest.
There's 10 different tests to see.
All right. So,
Oh, this is
I've got
yeah, this is not too bad.
good news for you and bad news for you. Actually, it's probably all bad news.
Can we hear bad words?
This was like, I got good news for you.
The news, just news, is that every day for this unit and next unit, you're going to have a quiz.
Is that include today?
No, not include today.
How's that good news?
So, the good news is you're going to get a lot of extra practice.
Are these quizzes
And the good
adjusted
news
by
is you do
test
well
score?
on them, or no?
Who knows? It's up in there.
Wait,
It's not AP style questions. It just is going to give you,
Would you like a time for a quiz?
it's going to give you a series, and then you're going to tell me whether it converges or diverges and what test you used to prove convergence or
Is it
divergence.
gonna be the whole
Would be
grade
tight.
or?
Huh?
We have to memorize all of them by next
No. We're learning 3 today, and then you'll learn like 3 more next class,
are those quizzes adjusted?
and then you'll learn
The next class, 3 are going to
4 more the next class.
Are they gonna be the actual quizzes?
What?
Are they affected by the grade adjustment?
Yes. So you'll still get grade adjustment at the end. For this first quiz, I'm gonna let you use your homework on it. So get your homework done by next class, so you can use it on
10
it.
rules on our homework.
You only need 3.
You want me to go?
It's only gonna be 3 for the first homework, or for the first quiz. But you need it because if you don't get practice like figuring out what test to use when, then it's gonna be really tough towards the end of this unit. The more practice you get, the better.
How many multiple choice questions can you get wrong?
There's no multiple choice.
No, I mean, on the AP test.
Wait, There's no multiple choice?
On the quizzes.
Oh,
Because it's
okay.
just like.
I thought you were on the
It's just a straight, does this
Because like
series...
the first one we do is just on the first three rules,
Yeah.
and then it keeps adding up.
Mm-hmm.
Factorial.
Mm-hmm. Oh, it's more like a just addition, like an arithmetic sequence.
I don't really know how
Just adding
factorials work.
3.
I never learned that.
Okay. So let's take a couple second or a couple minutes break.